Hey, this is Eric and Michelle with your first podcast for Mrs. Weber's Chemistry. This one's going to be about naming, and today we're just going to be dealing with naming binary compounds. So we're going to start out with going from the formula to the name, and then after that we're going to go from the name to the formula. So the first one we're going to do is going to be CO. And how you're going to go about doing this is you look at your periodic table and carbon, you can see that both carbon and oxygen are both nonmetals. So how you're going to name this is you're going to use the Greek prefixes. So since there's only one of each, the Greek prefix for one is mono. So you can go ahead and write monocarbon, monoxide, and you say oxide, not oxygen, because in binary compounds, every single compound ends in IDE. And for this one, since mono is in the first part of this compound, you don't need to say that. That's implied. So you just wind up with carbon monoxide as the answer for this one.
Bravo, Eric.
Our second one is going to be BaCl2. Now, when you look at your periodic table, you'll notice that Ba is barium, which is a metal, and calcium, or chlorine, is a nonmetal. So what you're going to do to name this one is, first off, you're just going to name your metal, barium, and then all you have to do is name the nonmetal with an IDE ending, which will be chloride. And that is your answer. Right?
Yes.
Okay, moving on, we're going to go to CO big O. Now,
Very nicely said.
CO, which is cobalt, is a transition metal, which means it has more than one oxidation state. So what you're going to have to do is look on your periodic table just above CO. You're going to find that there's going to be two black numbers. One of them is in bold, which is 2. I don't know if you can see that or not. Probably not. No, it's out of focus.
No.
There's a bold one, which is 2, and a non-bold one, which is 3. So what that's going to mean is that cobalt Oh, okay. I was thinking wrong. What you're going to have to do is you're going to have to choose between the traditional and the stock system. And for this podcast, we're just going to do the stock way because it is easier. So what you're going to have to do, since oxygen has an oxidation state of +2, -2 in this one, that means cobalt is also going to have a -2 because it balances out and there's no subscripts in this one. So since cobalt is +2, what you're going to do is name your metal, cobalt, and then you're going to put Roman numeral 2 in parentheses, and then oxygen with an IDE ending. So you're left with cobalt 2 oxide for that one. And then our fourth one in this section is going to be Al2O3. And when you look at your periodic table, you'll notice that aluminum only has one oxidation state, which is 3. Meaning you don't have to mess with any of this Roman numeral stuff. So all you do is you name your metal, aluminum, and then your nonmetal with an IDE ending, aluminum oxide. So that's that way. Now we're going to move on from the actual writing back to the formulas. So let's start out with something like lithium oxide. Now, look at your periodic table. You notice that lithium only has one oxidation state. So what that's going to mean is that the oxidation state on lithium is +1, and oxidation state on oxygen is always -2. Now, when you're writing these formulas, you have to make sure that these two numbers are balanced. And how are you going to do that? You're going to put subscripts right here and right here in your formula to balance that out. Now all you have to do is you have to say, well, how many lithiums is it going to take to counteract the charge on oxygen here? So since this is +1 and that's -2, the answer is going to be 2. So you look and you find the symbol for lithium, which is Li, and then here's your 2 to balance out the charge on oxygen, and then you have 1O. Li2O is the answer for lithium oxide.
And that would make the charge on that 0.
Yeah, net charge on all these is going to be 0. Alright, let's try another one. We have copper 2 chloride.
Very nice handwriting.
Alright, and what we're going to do here is you look on your periodic table, you'll find that copper has 2 states. It can either have a charge of 1 or a charge of 2. Now, the Roman numeral 2 here indicates that copper does actually have a charge of 2. So go ahead and put +2 above there.
It does not mean that copper has 2.
Yeah, that is a huge
as a
mistake
subscript.
that everybody has made and everybody will make, and hopefully we can stop it here.
It is not this. It is this.
This 2 does not mean this. This 2 means this. Charge only for the Roman numerals. Chloride, on the other hand, always has a charge of 1. -1. So now, as we did up here, try to balance these two numbers. So how many chlorides is it going to take to counteract the +2 charge on copper?
Why, I think it might need 2.
2 would be right. So you go CuCl2. Box your answer. CuCl2 is the answer for copper 2 chloride. Alright, let's have another one. Aluminum sulfide. Alright, looking at your periodic table, you'll notice that aluminum has a charge of 3. So go ahead and write +3 right there. And sulfur has a charge of -2. Now we're getting these numbers for the nonmetals because all of these elements have a charge of -1. All of these have a charge of -2. All of these have a charge of -3, and so on. Okay, what we're going to have to do is balance these two so that they're the same. So the number that 3 and 2 both go into, well, is going to be 6. So, what we're going to do is we're going to have Al2S3.
And 2 times 3 is 6, and 2 times 3 is 6, yep. It's balanced. And the charge equals 0.
Right.
Because there's a +6 and a -6 now.
So that is the answer for aluminum sulfide. So, now that we've done all these, we're going to have you try a couple on your own. So, the first one that we're going to have you try is K2S. So, how you're going to go about doing this is you have, since K only has one oxidation state, go ahead and just write potassium. And then all you have to do is name your nonmetal with an IDE ending. Potassium sulfide. Alright, and then the last one I'm going to have you try is calcium iodide. And how you're going to go about doing this is you look on the periodic table, and calcium only has one oxidation state. So Ca and iodine, and calcium has an oxidation state of +2, and iodine is -1. So you need to figure out how many iodines you need to counteract the +2 here, and the answer is going to be 2. So CaI2 is your answer. So that'll pretty much wrap up our first podcast. There's going to be more to come, and we look forward to doing them. See you later.